So I just had some fiber optic internet installed in our home. So I just wanted to go over really quickly how fiber optic cables work and the sort of theory behind that. So before we start on that, we need to understand how light works when it reaches a boundary. So if we imagine that this is some sort of boundary and this is one material and this is another, this could be, air or glass, air or water, whatever. We see that on either side we have this N1 and N2. And N is what we use to denote this quantity called the index of refraction. And the index of refraction basically determines, based on the material properties of whatever that material is, how fast light can travel through the material. So we know that there is one speed of light, but that speed of light is actually only for light in a vacuum. So when light goes through materials, the electromagnetic interactions actually cause it to sort of be interfered as it moves through. And this index of refraction affects how light behaves in the material and also how it behaves when it reaches a boundary between two materials of different indices of refraction. So light has basically two options. When it comes in and reaches this boundary, it has the option of either being reflected, as we see here, or being transmitted, which just means going through or being refracted when it transmits and then sort of changes angle a little bit. And what determines how the light behaves at this boundary is the index of refraction. So if you have a higher or lower index of refraction on either side, some of the light may be reflected or some may be transmitted, and more may go either way. But if we have a scenario like what happens in a fiber optic cable, we make the cable out of a special material that has a very high index of refraction. So that way, once the light gets inside, as long as it hits the walls at the right angle, it becomes trapped. And this is known as total internal reflection, which just means that when the light hits the boundary, none of it wants to go out. It wants to stay in because of the higher index of refraction inside rather than outside. So once it gets in, it's trapped, and as it hits the walls, it just completely reflects back the other way. And so if we make a cable out of this material, we can trap the light within this cable so that it just continues bouncing around through the cable all the way until it reaches the other end. However, this is, as I said, dependent on the angle at which the light hits the side. So if you bend a fiber optic cable too far, not only do you risk breaking the actual cable material, but you can also reach a point at which the angle that the light hits the walls is too steep or not the right angle. Because this phenomena is all dependent also on the angle that the light hits the wall. So if you bend the cable too far, you'll have a bad angle, and then some of the light will actually transmit through the wall, and then less will be totally internally reflected. So in reality, all cables normally have some losses, and especially based on how they're built and constructed, the angle may not be good, so you may have some transmission through the outside. But in general, fiber optic cables are a great way of transmitting